Hey everyone, this is our lesson on work and power. And by the end of this lesson, you should be able to explain work in terms of relationship between applied force on an object, the displacement of that object, and the energy transferred to the object. So it could be any of those components. So first, let's make sure we understand what work is. So work is the transfer of energy through motion. And when we look at energy, remember energy is either transfer of heat or doing work. So now we're looking at the work part. We've talked about the heat part. Now we can talk about the work part. So when we look at work, we're looking at force exerted on an object and the distance covered as that work takes place. And the amount done depends on the amount of force applied and the distance that the object moves due to that force. So our formula is work is equal to force times distance. So W is equal to FD. Remember here, W is not weight. That's F sub W. So that's why we use a capital W here. Our unit is a joule. So remember, joules are for energy, and since work is a component of energy, we use the same unit, so a joule. This is also, you could see it if you do your math and you forget that a joule is the unit for work. Remember that force is measured in newtons, distance is measured in meters, so it could also be defined as a Newton meter. So let's go ahead and quickly look at an example problem here. So this says the force of 12 newtons is needed to push a suitcase across the floor a distance of 0.5 meters. How much work is done? So we've got our basic information from this problem. The force is 12 newtons, distance is 0.5 meters. We want to know the work. So we're going to take those two values and multiply them together based on our formula. And when you do that, it comes out to 6 joules of work are needed for this to happen. And then again, remember your unit can be written as Nm as well, capital N. So I'm going to go ahead and get rid of my video very quickly so that you can pause your video and try this example. All right, so now let's talk about factors that affect work. And there are two factors that we look at that kind of determine how work is being done or when work is being done. And the first thing is something has to move. Distance is a component of your work calculation. So if there's no change in distance, so D would be equal to 0, no work is done. And also the motion must be in the direction of the applied force. So if I'm pushing an object forward, your direction needs to be forward. Okay, so if you look at this picture over here, you can see positive work where the force and the movement are in the same direction. And then you have negative work where the force is pushing and your object's going in the opposite direction. So a push is positive work. Friction is negative work. So you know that you can overcome friction when you push something because friction is just an opposing force, but not one that should be stronger than you. So you pushing would be a positive force, but if you look at it in terms of the work the friction is doing, that's negative. Gravity, which is when an object is moving horizontally, is 0 work. So we know that gravity is a force that is vertical. So if your object is moving horizontally, gravity only affects it vertically. That means there's 0 work being done by gravity. So gravity is not affecting that object because it's not moving up or down. So when movement is horizontal, then no work is done by gravity. So now let's go ahead and look at this example. And I've given you a hint here to help you set this one up. So that says find the work done by gravity when a 2-kilogram rock falls 1.5 meters to the ground. So here, since an object is falling, gravity is doing work. Okay, because we know falling is a vertical movement. So here my hint says work makes you mad. This is important because this actually gives you the calculation that you need. So mad is our calculation. where M is mass, A is acceleration due to gravity, and D is distance. You actually need all three of those here to figure out work. So we know we have a 2 kilogram rock. Our acceleration due to gravity is 9.8 meters per second squared. Remember, that's a constant. And then we have the distance of 1.5 meters. We're going to multiply all three of those together. And we're going to end up getting a kilogram times meter squared per second squared. Remember, kilogram times meter per second squared is a Newton times meter. That's going to give you a joule again. So it comes out to 29.4 joules. So you go ahead and pause the video and try this example. Now let's get into power very quickly. So power is defined as the measure of work done in a certain amount of time. So now we're not only looking at the force applied over a distance, now we're looking at that same force applied over distance within a certain time frame. And the formula for power is work divided by time. So you can have a calculation triangle here if you want one. Want this in your notes. So you've got P is equal to W up top over T. So you may want that in your notes. Work is on the top of your triangle. P is on the left bottom and T is on the right bottom. Your unit for power is known as a watt, so a capital W. That is 1 joule per second, so that's the unit. It's named after James Watt. And it's so small that we often express this in kilowatts. So like in normal measurements we use every day in terms of power, we use kilowatts. And remember, the prefix kilo is 1,000. So 1 kilowatt is 1,000 regular watts. So now let's go ahead and let's try this example. So a set of pulleys is used to lift a boat weighing 1,980 newtons. The boat is lifted 2 meters in 55 seconds. How much power is required? So we've got that the time is 55 seconds. We need the work, but we were given the information needed to calculate work, which is force times distance. So our force was 1,980 newtons. Our distance was 2 meters. So when we get that, that comes out to 3,960 joules of work. We're going to take that and divide it by our 55 seconds. And our power comes out to 72 watts. And then again, if you want to practice writing them in kilowatts, you would just move the decimal 3 places to the left. So now it's your turn. Go ahead and try this example. Pause your